Okay, so you've definitely seen these already in Algebra 1 and Algebra 2, but we're just going to review them real quick. So exponential functions are where x is in the exponent. I'm just going to zoom in so I can actually write in this. So these are the ones where we have f of x equals a times b to the power of x. Okay, so when we do this, a is always going to be your starting value. Starting value. So, for example, and I can't really write this with how much space I have and what I'm using, but something like if you put $100 into a bank account, that would give us f of x. You would start off with that 100. Okay, and since you're multiplying it here, for it to work out, it has to be any number except 0. So a is not allowed to equal 0. Okay. The next piece of this, the b value, is how much you are increasing or decreasing by. Okay. So if you were, if we're talking still about a bank account and you had a 5% interest, then we would write that up here as 1.05. And that is due to, if we're increasing for it to be bigger, to multiply something and for it to be bigger, it has to be larger than 1. Which brings me to my next point of my restrictions. So just like this guy, b cannot be 0 because if you multiply by 0, nothing's going to happen. But it also can't be 1 because then you're not going to get that growth or that decay that you need. Okay? So just some things to keep in mind. And then x is going to have no restrictions at all. It can be any number because that's your input. And for our example, it would just be like how many times you get your interest. So the number of years or days or whatever it is. So the number of, it's usually the number of something, honestly. Maybe the number of months, something like that. Okay. All right. But x is just your input. You know how I like to put everything in terms of input and output. Okay, so we got two little examples here. I want you to do a couple things with these. I want you to identify what the input and output stand for in terms of the problem. That's actually going to earn you points on tests and quizzes. And then I want you to write the actual equation out where you're going to leave x as x, and then there's usually a question involved where you're going to have to input something and give an answer. So make sure that you're giving your answers in sentences. Okay, so a researcher found that the number of bacteria in a certain sample doubles every hour. Okay, right away, my input is going to be the number of hours because that's how long this is happening. It's happening every hour, gives you that piece. So that's what your x stands for. The fact that it doubles should hopefully clue you into the number 2 rather. And since that's what's happening each time, that's our b value. Okay, and then since we're talking about bacteria here, our output is going to be the number of bacteria. Okay, and then this is a really good place if they had said that the bacteria were like in tens of thousands, you would want to put that here with it. And I'm sorry that my writing on this is so bad. My stylus is not the best. Okay, so our initial value is our A. So if there were 6 bacteria in the sample at the start, so we're starting off by 6 and we're doubling, how many bacteria will there be after 9 hours? So that's really direct. So it's just raised to the x. So that's part of your answer. And then you're just going to substitute in 9 to solve for this specific problem, okay, which should end up giving you 3,072 bacteria. Make sure you put that in a sentence for me, okay? So after 9 hours, there will be 3,072 bacteria. Okay, so this would be an example of growth. This guy is growth. And our next little example here is going to be decay. So if a tray of water is put into the freezer, its temperature will begin to decrease right there. That's what lets you know that this guy is decay. Okay. And we're talking about temperature going down. Okay, so I know that my end result is going to be a temperature. Okay. And if we start off with 65 degrees, there's your A value. So we've got 65 degrees and loses 20%. So here's the part where you need to be a little careful. Okay, because it loses 20%, I'm not putting 20% in here. Your equation is letting you know what the temperature will end up being. So instead of thinking I'm losing 20%, you want to think about how much of your temperature are you maintaining. And since I'm losing 20%, I'm maintaining 80%. Okay, so 0.8 or 0.80 if that makes you happier to think of it in terms of percentages. And then raised to the x power. Okay, so x is every minute. So it's the number of minutes since you started or since you put the tray in the freezer. Okay, and then we want to know when it's going to be less than, why does that not want to erase? We want to know when is it going to be less than 5 degrees. Well, 5 degrees is an output. So we actually are substituting this in for our f of x. And we will talk about how to solve things like this a little bit more by hand, but you can use the technique that we've been doing in class where you put this into your y1 and we put this into our y2 and we find the intersection of the graph, and that will give you the answer in this case, which is kind of nice. Okay, so I'm just going to sketch the little graph that you should end up with here. We have our little graph. You should have decay, so it's going like this. And we have our value of 5 going across, and we find our intersection, which in this case happens to be about 11.5. Okay, and since the output was degrees, so at 5 degrees, like what happens at 5 degrees? And it's that it takes 11.5 minutes to reach 5 degrees. Okay?